Hello, hello, hello. Am I live? I should be live at this point. Hello, hello, hello. Am I live? Yep. All right. Looks like we are good to go. Things are streaming. Um, so we are going to continue with our quest of reading through the Lingua Franca. Lingua Franca. Gotta say it right. Lingua Franca. I still think I'm not saying it right. Lingua Franca. Lingua Franca. Lingua Franca. Eh. Anyway, that programming language, the Lingua Franca programming language. Yes. So I think last time we got two reactions. La 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 la. And yeah, just double checking that we've actually been through all this. Yes, I recall going through all of that, and there was attention paid to the fact that the execution of your reactions are deterministic based in the I think it's based on the trigger and the alignment of the reactions within the reactor. All right. Okay, so today we are starting from here, reaction declarations. All right. Sometimes it is inconvenient to mix lingua franca with target code rather than defining reactions complete with inline target code. It is also possible to just declare them and provide implementations in a separate file. That's actually pretty neat. The syntax of reaction declarations is the same as for reaction definitions, except they have no implementation. Reaction declarations can be thought of as function prototypes. Okay. And then you just, I guess, link them. I'm guessing the name here, they need to match. Okay, the CMake, okay. And I wonder if this is, well, sounds like this is mostly, yeah, specific to C and C++. What's interesting though is that for C++, you don't even have to define the files like you do with C. Wonder what that is. Okay. The blah blah blah, the CMake target property is used to make the build system aware of an externally supplied implementation. Okay, the contents of hello CMake is as follows. Target sources, main target, private hello C. The file's target property is used to make the file that has the implementation in hello C accessible, which could look something like this. File structure. In the above example, the C file used the include hash include to import a file called hello declaration, so a header file. This file was generated from Lingua Franca source file when the LF program was compiled. Oh, so this is a reverse. Up until now, I thought we were talking about bringing code from the external world into Lingua Franca, but this specific thing here is doing the opposite thing. It's bringing a Lingua Franca compiled program or source file. Yeah, compiled. Okay, so the file hello declare is named after the main reactor, which is called hello declare, and its parent directory include hello declare is named after the file. Okay. In general, compiling a Lingua Franca program that uses reaction declarations will always generate a directory in the include directory for each file in a program. This directory will contain a header file for each reactor that is defined in the file. As another example, if an LF program consists of files F1 and F2, where F1 defines reactors A and B, and F2 defines reactor C, and the main reactor F and the main reactor F2. Okay, all right. Then the directory structure will look something like this. Let's see. So that's A and B, F2, C. Okay, so each reactor gets its own header file. There's no particular location where you're required to place your C files or your CMake files. For example, you may choose to place them in a directory called C. That is a sibling of the source directory. By the way, so does that mean that you could technically run a compiled LF program inside another LF programs? I guess thinking about composition at an even higher hierarchical level. Well, I mean, you already have composition at the reactor level within a single, I guess, main reactor. But then even that, you can compile that as its own thing. And then we use that in other reactor programs. That's my understanding from this. The generator header files. The generator header files are necessary in order to separate your C code from your LF code because they describe the signatures of the reaction functions you must implement. Oh, wait. Okay, I think, and I don't know if all of this workflow here strictly applies to when you just have declarations and you don't actually have the specific implementations. So really, you really are using Lingua Franca here as a framework for the state machine, for building the state machine, and then in your primary or real code, that's where you actually provide the implementation for the reactions. That's actually pretty neat. Because, I mean, that's quite flexible actually. But it sounds like this is only available for C and C++ though. So it's the same story with C++. You can import it, import the generated code, and then use it in your main program files. The precise method signature depends on the name of the reactor, the name of the reactions, and the precise target, and the precise trigger sources and effects that are defined in the LF code. The return time is always void. A reaction full in a reactor bar will be named bar inner full. Makes sense? Know that each reactor class in a C++ target defines an inner class which contains all reactions as well as the parameters and state variables. This is done to deliberately restrict the scope of reaction boundaries in order to avoid accidental violations of reactor semantics. Any declared triggers, sources, or effects are given to the reaction method via method arguments. The precise arguments and the types depend on the LF code. If in doubt, please check the signature using the generated header file on the generated source file. Do they say the same thing for C? Yeah, they don't talk about any of that for the C one. Alright, let's go to methods. This is a pretty short one, pretty straightforward. Definitely like the idea of it. It makes it easy to, as a buy-in, if you think of this as more so of a framework for building state machines that you then want to include in your programs, then this really works for that. Methods, method declaration. This article has examples in the following target languages: Python, C++, C. Sometimes logic needs to be shared between reactions. In this case, methods can be used to implement the shared logic, and these methods can then be called from reaction bodies. A method declaration has one of the forms. So you have the name and the type. Is this meant to be the return type? I think. Argument name, argument type. Okay, seems pretty straightforward. The first form defines a method with no arguments and no return value. Yeah, I think all of this is pretty straightforward. Finally, the fourth form is similar to the third one but adds a return type. Yeah. So name, argument type, and a function return type. That's pretty typical in typed languages. Methods are particularly useful in reactors that need to perform certain operations on state variables and all parameters that are shared between reactions or that are too complex to be implemented in a single reaction. Analogous, I feel like I'm pronouncing that wrong. Analogous Okay, we'll just roll with it. Analogous to class methods, methods in Lingua Franca can access all state variables and parameters. Class methods. Sorry, my brain went somewhere and came back. I was thinking about something related to, I don't know, it's not worth mentioning. Anyway, I'm back. Methods in Lingua Franca can access all state variables and parameters and can be invoked from all reaction bodies or from other methods. So, I mean, typically we could just call them functions. It's just, I guess these are scoped inside the reactor, right? Yeah, that's what it sounds like. Methods, blah, 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 and can be invoked from all reaction bodies or from other methods. Methods may also recursively invoke themselves. Consider the following example. So, okay, we have that method, get foo. Okay, so returns an int, self foo plus 1, plus x, so now we're modifying. I don't love that you can look at a method or the way methods are specified. There's no way to immediately know without looking at the implementation details. There's no way to know if this is modifying state as in having side effects. You could make the case that doesn't matter because ultimately they're meant to be used within reactions, and so at that point it's the responsibility of the reaction to declare all its side effects on the state variables, since it's the one invoking all these methods. And I think that, although I think that works maybe in simple cases, but the more complex the execution of the reaction becomes, and by that I mean the more methods are involved and the more complex each of those methods are, it becomes a bit of a challenge unless you have somewhere to automate the check, like as part of the compiler that's generating the program. Like there is a way to check that, hey, you've declared your reaction a certain way, but based on all the methods that are being invoked, here are the side effects, and you have not, as in, here are the side effects on the state variables, but you haven't declared those as like here. My understanding is that, okay, maybe the startup reaction is different, but my understanding is that since method add is modifying foo, then there should be a foo here after startup. But I don't know if the startup reaction is meant to be special in that way. Let me see. It was not overriding. It was something. Was it here? State declaration. I mean, yeah, by default, I get that they are optional. Note that the reaction body may only read from actions and ports that it has declared as triggers or users. And it may only write to actions and ports that it has declared as an effect. Yeah, and so I guess going back to what we were just talking about, wouldn't the foo state variable be, I guess it doesn't specify state here. These are just actions and ports. Okay, maybe that's the difference. Okay, I think that might be, well, we'll see. For now, we'll just assume that the declaration rule doesn't apply to the actual state elements of the reactor. Like, you don't have to declare them in the reaction to indicate that you plan on modifying them. So I don't think I love that. Like, you know, just not knowing that there is a modification on the state happening without having to look at the details of the implementation. I don't love that. Because if this was a complex method here, and you even have multiple variable updates, it's easy to lose track, basically. So, I don't know. I don't love that. Okay, I guess we are at the end of this one. This reactor defines two methods. Get foo method receives no arguments and returns an integer indicating the current value of the foo state variable. The add method returns nothing and receives one integer argument, which it uses to increment foo. Both methods are visible in all reactions of the reactor. The reaction to startup calls both methods in order to read and modify its state. Alright, causality loops. Value 125. Alright, cycles. excuse me. The interconnection pattern for a collection of reactors can form a cycle, but some care is required. Consider the following example. So you're taking the input, you have an output, start up, a reaction X changes. At startup, we make a change to Y. Okay, so we have instances and then a Y, let's see. Okay. A1 goes to BX, which will trigger this, but this also will be triggered. Start up. Oh, interesting. This is interesting. I hadn't thought about this. So there's always a startup react. Well, there's not always a startup. If you attach one to the startup event, then there'll be one. But up until this very moment, I hadn't considered the fact that you don't have to write this reaction, the startup reaction, as the first reaction. In fact, if you want to go to the extreme, you could put it last. In fact, you could put it, I mean, as far as I'm aware, they haven't hinted at the fact that the compiler will yell at you. So if you put the startup reaction all the way to the bottom, even after the shutdown reactor, in fact, to be silly, why don't you put the oh my gosh. Shut up, Siri. Okay. Oh my goodness. I can't even right now. I mean, I was freaking out there for a second. I was like, wait. I did just hear somebody say hello, right? And of course it's, yeah, they're always listening. But yeah, so if you put startup all the way to the bottom and then you put shut down all the way to the top, or to make things more interesting, let's say there are at least 3 reactions, 2 of them being startup and shut down. You put startup all the way to the bottom last. You put shut down as second, and then you just place the others in whatever positions. Does that mean that, because I guess what I'm trying to reconcile here is the placement or position of the startup and shutdown reactions, and the fact that reactions are supposed to execute in the exact order that they are declared, or I guess aligned within the reactor. So if we go by just that rule, then in theory this needs to run before this. But I don't think that is not intuitive though. Like if there are 20 reactions and for whatever reason this ends up being the last one on the list, I will still not expect it to not run first on startup. So I don't know what the deal is with that. That's something I look forward to getting an answer to at some point. But for now, let's stick with the subject at hand. Okay, so you're sending it for A, you're sending it to B via the Y output port here, and that goes into the X, which, wait, what? Oh, okay, I was looking at the wrong thing. Oh, supposed to be all the way up here. Okay. Alright, so Y goes into X. X gets triggered. Technically, it also gets triggered here. So yeah, I don't know which one is supposed to run first. I guess probably this. And then this. Yeah. Which goes to Y. But then that Y is connected to X. And that X is connected to okay, that exchanges, which then goes to Y, and then that Y goes to X, and this goes on. Wait, but on the second round, this Y goes to the X gets triggered. Wait, wouldn't that stop? Yeah. I mean, without knowing what's happening here, because this does not necessarily mean that Y is being updated. In fact, just looking at this feels like a read-only thing. Let's see. The diagram highlights a causality loop in the program. At each tag in reactor B, the first reaction has to execute before the second if it is enabled. A precedence indicated with the red dashed arrow. Okay. So the startup, excuse me. So going back to my earlier comment about, the placement of startup and shutdown, it does sound like it doesn't matter. Like it's exempt for, or the fact that the startup reaction needs to be the one that runs first, always, all the time, overrides the reaction placement rule as well. But the first can't execute until the reaction of A has executed. Oh, okay, so that's where so this is wrong. Okay, so I guess that validates my concern. So, okay, the first can't execute until the reaction of A has executed, and that reaction cannot execute until the second reaction B has executed. I'm making sure that I'm really understanding this. Okay, so going back here, we have the instances. We have AY that goes to BX. But in order to get values into Y, X needs to be executed first, which doesn't seem to be the case here. Like there's nothing triggering this reaction initially. Like it won't trigger on its own or something. Even though it's supposed to react on X and then send a value to the output Y, which is then connected to this BX, and the output port Y is connected to AX. So this is the only way by which this reactor is doing anything useful. But this cannot happen until this happens. But this cannot happen until this happens. No, well, yeah. Yeah, okay. So I guess I just want to make sure that it is in fact true that this position here is wrong. Well, if this was at the top and this was at the bottom, then then a startup Y will send a value, BY will send a value to AX, which will send a value to BX. So yeah, the reason why this is broken is because this here comes after this. That's my verdict. Let's see if I'm wrong. The first reaction has to exit. Okay, so each tag in reactor B, the first reaction has to execute before the second if it is enabled, right? But this violates the whole point of having a startup reaction. But the first can't execute until the reaction of A has executed. Okay, that's true. And that reaction cannot execute until the second reaction B has executed. So there is no way to satisfy this requirement. So the tools refuse to generate the code. I think it's basically saying what I'm saying. I think the crux of the issue here is that these are not congruent according to the execution model of the runtime, of this runtime. Okay, let's move on. Cycles with delays. One way to break the causality loop and get an executable program is to introduce a logical delay in the loop. Okay. What's that? Interesting noise. Oh, I don't know. I feel like wait. I don't know. It doesn't seem like this order here is being emphasized. So I might be wrong on my what I assumed was definitely the cause of the causality loop. So AY goes to BX after 0. So after the initial step or epoch of the state machine, after which this would have run, right? Yeah, so this basically allows the startup reaction to get things rolling, I assume. Which, when that gets rolling, it goes here. Oh no, sorry, it goes here because of this here. Sorry, I'm saying this. So on startup, on the very first iteration of the state machine, or first step, first epoch, this will run, this won't, even though well, okay, no, let's just forget about this for now. We're just on startup. There won't be any trigger for this on the initial epoch, just this one. So, and that will go into the output Y port, which connects to the X port of A, which triggers the reaction here into Y, the output, and then that comes here. Yeah. Here we have used the delay of 0, which results in a delay of 1 microstep. So yeah, microstep or epoch, a step of the state machine. We could equally well have specified a positive time value. Reaction order. Frequently a program will have such cycles, but you don't want a logical delay in the loop. To get a cycle without logical delays, the reactions need to be reordered. Yay! Alright. Finally. This validates my understanding of how things work. So yeah, so it was a matter of rearranging the startup reaction, right? Okay. Good. That's nice. Means I'm understanding how things are supposed to work. Alright, let's see if we can get through this one. Oh, it's a short one actually. Maybe we'll even make it to actions. Ooh, actions long though. May want to reserve that for tomorrow. Alright, let's go through this. Extending reactors. I don't know, depending on when we end this, we might look at some code, some open source code, or we might read through some ontology stuff. I've been meaning to do that actually. I want to experiment with building ontologies. Whatever the fuck that means. Well, okay, I know what that means, to be fair. Because Palantir won't shut up about it. For a good reason. Especially in this age of AI, capable AIs. It really makes sense for more attention to be paid to ontologies or how to build one. But let's focus. Blah 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 blah. Which specifically was I? Okay, I think it was this one. Extending reactors. This article has example in the following target examples. Oh, target languages: Python, Rust, TypeScript. Let's go with, I don't know, Python. It's the same, should be the same documentation. Extending reactors. Please tell me there was only one level of subclassing. Please. I'm begging you. Please. Okay, extending a base reactor. Lingua Franca supports defining a reactor class as an extension or subclass, as in the following example. Alright, reactor A, input A, output, blah, blah, blah. Extend A, so it looks like what's happening here, it's gonna eat up all the inputs and outputs here. Okay, so yeah, so you don't, it works as one would expect. That way you can reuse definitions over and over again. That's cool. Okay. Here, okay. The base class A has a single, I don't want to read through all this. I mean, it's pretty straightforward. Well, okay, no, let's do it. The base class A has a single output that it writes to in reaction to an input. The subclass inherits the input, the output and the reaction A, and adds its own input B and reaction. When an input event A arrives, both reactions will be invoked, but once again in a well-defined order, meaning that this will always run before this, right? The reactions of the base class, yep, are invoked before those of the derived class. That's what I would have expected. So in this case, B will override the output produced by A. Let's see, let's double check that. Reaction A. Okay, so the first one will update the value of A, and then it does it again. No, okay, no, what am I saying? The output is being updated here once, and then here again. One thing. Yeah. Okay. Yeah. So this will be the one that sticks, basically. The reactions of the bakers are invoked before those are derived. Blah, blah. One limitation is that a subclass cannot have ports, actions, or state variables with the same names as those of the base class. Makes sense. The names must be unique. Okay, makes sense. A subclass can extend more than one base class by just providing a comma separated list of base classes. If reactions in multiple base classes are triggered on the same tag, they will be invoked in the same order that they appear in the comma separated list. Makes sense. But then again, I hope it's again only one level of subclassing and not multiple. And the fact that they don't mention multiple levels of subclassing gives me hope. So yeah, okay. I think we'll pause here for reading the manual on Lingua Franca. Tomorrow we'll pick back up with actions, these next 3 chapters. I think this should be interesting. I think I saw a talk about this recently where they talk about why it's useful. Yeah. All right, let's see. What should we do? I did mention looking at actually, let me see if there's some new content. Programming language. Well, besides my own stuff. Oh, and yeah, if you guys care about this Lingua Franca stuff at all, you should watch Edward Lee's channel. As far as I'm aware, he's the main driver behind the project. Obviously, his work. He has people who I don't want to say working for him, collaborating with him, both as I think PhD students, but also researchers. That's my understanding. Anyway, but yeah, I think he's the main person behind the project, and my understanding is that he's been working on this for years now. And I think I saw a talk where I think he, at some point, I think decades ago, he did a research paper so relating to basically coordination and clocks in distributed systems, and I think My understanding is that it sounds like Google Spanner took some inspiration from it when they were coming up with a what they call it? Is it atomic time that they call it? Google Spanner, atomic. Oh yeah, atomic clock. There it is. True time. Yeah. Anyway, you guys should check out his channel. He has most of the Lingua Franca stuff on it. Oh yeah, I also saw this.
Hello, in this video
I'm
I will
listening
show
debugging.
the result of the operational semantics tooling in the Gmod Studio for Lingua Franca. Okay, so just a quick thing about the definition of the semantics. I explained it in a previous video. So here it is. We got two parts. First, the MoCaml part that defines some new events which are woven in the context of the language concepts. Like for example, in the context of a reaction, I've got a synchronous
This guy
execution,
sounds like such.
and it actually calls some rewriting.
Sounds like such a French person. Which is, I'm not. That's great. Just. Um, it's just interesting. Gonna get a follow from me. Oh, is he working on his own meta language now? I think so. Sounds like he was inspired by the Lingua Franca, maybe. Rabbit hole. Yodeling. Language that can program itself. Oh no. What kind of demonic shit is this? What am I supposed to do here? Yeah. Okay. Oh, I'm just supposed to click on enter. Oh, okay. So let Alice is parent of Bob, and now you're expressing that as as a statement or something, as an expression. So when somebody says Bob is child of Alice, you can make sense of it. Like you can reason about what those. Oh, it compiles to WebAssembly? Is that what it's saying? That's a rabbit hole right there. Just gonna do that. And install and move on for now. Okay, let's do something useful. Has he done published anything recently? Oh, he's a professor now. Hmm. Won't be reading through all of that right now. I think I'm gonna sit down. Okay. All right. Special issue. Where are the actual entries? But I want to say the actual. Can't see the actual content. Didn't this already release? Yeah, that's fine. Yeah, GMAC. I think that was the editor he was using. Going back to this here.
In words which are defined in Kermeta 3. Okay, so this is Kermeta 3, so it defines the runtime state of the model. So for example, the current time, the current microstep, and the starting timer, which are event.
Right. I have to zoom this in. I don't think that did anything.
And some rewriting rules, like the one you just saw before, the execution of the reaction, which here just makes some printing. Okay, quick numbers. This file is 351 lines long, and this file is actually about the same. This is new, so yeah, 354 lines long. So this is the whole definition of the lingua franca operational semantics so far. Okay, so let's see the result with this. So I've got my AutoWare example here, which is there. I can decide to launch a debug configuration of a Gmod concurrent executable model. I will just name the configuration AutoWare debug. I will pick the model to execute, so I want to execute AutoWare.lingua franca. And I want to use the semantics I just defined before. Just a quick note that we can define several operational semantics for the same syntax. Okay, so here I pick one of them, which is only one. Before to run the debug, I will add some add-ons. So I will choose the KLite animator and the multi-control effective phrase I will show you just after. Okay, and I launch the debug. When launching the debug, so I can see the status of the engine here, the trace here, which we
can see
and the next future.
The other side because I'm so zoomed in.
Have some output and console. The current time is 0 microseconds and the run microsecond is 0. So at this time in this model, what I can do is that I can start the camera timer or start
it's unfortunate that
but I can do
it's so
or both together. And these three possibilities are the one we can show here, which are exactly the same thing. Okay, so let's decide to do some, for example, a LiDAR first. So I do that. So what you can see that the LiDAR actually starts. It's showing in the console that it starts, and the event list now has a new items, which is the fact that the LiDAR timer should release at 100 microseconds and microsecond 0. Okay, and I can see that it actually shows this blue possibilities along the green one, and I know in the new step I can do a single thing, which is starting the second timer because I cannot do anything else. So let's do it. So it starts, it adds the corresponding scheduled action in the event list. I know I cannot do anything else but a time jump. Okay, meaning that all the causalities are solved in this model, and the next thing I can do is actually jumping in time from 0 microseconds to the next action to do, which is here 100 milliseconds. So let's do it. Just do it. I'm now in 100 milliseconds. And now what I can do is asking if this timer can actually release.
So this allows you to actually step through
both release.
One.
The only action I can do is the release of the different timers, which can be done once again in any order here. So let's do them together again. So they release now. Here we can do many things. Okay, so we can execute this reaction, restart this timer, and any combination of these things. So I will choose a bit randomly these things, but the order is important for the causalities here, but not important from the timing point of view because we stay in the 100 microsecond 0 microstep instead. Okay, so let's do it. So yeah, we start the camera timer, I restart the LiDAR timer. I execute this reaction and the update of the image here and here. I execute the C here, there are causalities, so because I did this first, so now I can actually execute this reaction here and start this action there. Okay, so what can I do? I can also execute these reactions and later on execute these reactions there and start the timer here. Okay, and this order is actually not totally relevant because at the end we end up in a state where all these things have been executed and the only thing we can do is a new time jump. Okay, so we can see that now in the event list we have 4 actions. The camera timer,
if I'm being honest, most of this is just curiosity. I don't think I'm actually
and we can have all these different actions here. These timers, execution of these actions, also execution of these actions which are possible. Okay, and
learning something specific here, except for this is something to explore. The GMARC Studio Omnisign Debugger. Oh, this is nice. So you can define some sort of DSL and then test. Like you can define the semantics of a DSL and then test those semantics. That sounds like, because I mean it's called excuse me. A framework for designing and integrating EMF-based modeling designs. The framework provides a generic interface to plug in different execution engines associated with the specific meta languages used to define a descriptive and operational semantics and the behavioral coordinations, ESLs. It also integrates generated runtime services that are shared among the approaches used to implement the execution semantics, such as graphical animation and omnisign debugging. GMARC proposes a framework to integrate any kind of meta programming approach used to define discrete event operational semantics into an execution engine. Oh, last thing was last update was 2023, which is not too long ago. Oh, it's on GitHub too. Last month, updated. Alright. Alright, so what did I say I wanted to do? Something ontology. Something ontology. Something ontology. Is that what we're doing? Engineering design, optimization. How did I get here? Oh. Let's see. Oh, the TLD is open. And get hash. Get on the simulation. Turn word protection. So what's on the roadmap? Delete bugs. How did I end up with this? Open. Which class is this? Oh. I think this was supposed to be the... Wait, oh no, yeah, I went through chapter 1 of this already. This is chapter 2. Okay. What is this? Klein. Yeah. Blah, 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 blah. Okay, that I remember. Yeah, okay. Process as a service. Years old. Huh? I've updated artifacts. Okay, maybe we should look into some. Oh, but it's 10 p.m. yo. Let's see. Let's see if we can quickly watch some. I don't think I'm gonna do the ontology thing. I mean, why not? You can probably do another 30 minutes of just ontology, right? It's either that or watch something programming related. Listen al Gaib. What engineering looks like in 2000.
Of our product every 6 to 12 months. Every 6 to 12 months, it should make our existing product look silly. It should almost make the form factor of our existing product look dumb.
How do you know when it's time to hire someone?
I wanted the company to almost be like this dehydrated entity. Every hire is like a little bit of water, and we only go back and hire someone when we're back to being dehydrated.
Any other skills you think people should be investing more in with the rise of AI, building more and more of our products?
The engineers are now able to produce more technology. The ROI of building technology has actually gone up. This actually means you hire more. The best thing to do is just get your hands dirty with all of these products. You could be a force multiplier to your organization in ways in which they never even anticipated.
$207,000 with my AI.
Yeah, okay. I don't know. I think I just want to look at my ontology documentation. Oh, I remember watching this. Very interesting UX research.
So I'm very excited to be here to share the research we have been doing in the Foundation Interface Lab at UCSD. I've been very fortunate to work very closely with my wonderful colleague Jim Holland and a bunch of my amazing PhD students. So
I definitely
in our
recommend.
lab, the overarching research question we are exploring is
recommend
what are the
this.
foundational principles of a productive and convivial information environment?
Not gonna go through the whole thing, but
actually have a slightly different goal, right? They may want a slightly different interface, and they may want different pieces of information and functionality. So this is also true just for just collecting information, right? The author of that article couldn't predict, right, what kind of information needs the readers will want. So David Carver phrased this really well. He said that no developer can predict all the ways a user will want to record, annotate, and manipulate information. Right? So here's an example for you guys. So this is the Airbnb app. I use it a lot to find a place to stay when I travel. Now, when I look for places to stay, I care about both the price and the rating, right? But if you look at the interface, there's no rating on the map, right? For me to see the rating, I have to click on each individual one, and then the details will show the map, show the rating, right? And you may say, well, there's a hard design trade-off. There's not much space on the map. We can't display too much.
I think the thesis here is that with the advent of AI and all that, more than ever, we have the opportunity to really rethink, which I feel like if Steve Jobs was alive, this is the sort of thing that he would definitely be pushing for, I think. Like the idea of just rethinking the way we interact with, digital interfaces. I don't want to say computer because I feel like that's a little too broad. I think specifically with user interfaces, and the fact that there's more that we can do now. And I think what they came up with is this thing where as you are communicating your intent to the UI, in terms of, I'd say, I think the example that I use here is making dinner, making plans to go out for dinner or something. And the UI basically puts together some sort of model of, I guess, the goal, the target, the activity. I think they call it activity here. And based on that, it decides how to render certain pages or windows.
Workflow. So at the end of the day, we suffer from very fragmented workflow, right, and really challenging information management. And just on a daily basis, we have messy desktop and have explosion. So I think this is the problem of the application-centric interface paradigm. We have rigid containers and bloated containers. We have fragmented workflow and challenging information management. And now we have AI, right? Things should be better. So let's take a look. So last week, I got my hands onto OpenAI Operator for $200 to be able to use it. And so, I was trying to test it with a case of organizing a dinner party because it was the Chinese New Year. So I opened it. Here's, sort of like my interaction with it. So I started with, I'm thinking about organizing a dinner party. So he replied with these chat messages like, here are the things you should think about. I'm like, cool, that's useful. I probably will start thinking, about the menu. So I, followed up with Operator and, gave it more, Operator asked me about my preferences. So I replied, and then it will give me this initial menu. Well, so, I was curious, right? So I was like, okay, give me the recipes of these menus. Then the operator, goes ahead and does this kind of job, right? It opens this browser already. And so it will just, copy the text from the chat, search the recipes online, and, this is sped up like 5 times. Okay? So, just doing all these browsings. And then after, I think, 5 minutes or maybe 4 minutes, it returned and sort of this list of menus and recipes with links, right? So I wasn't very happy with it, to be honest. But I was just trying to keep it going to see, where things will break, right? So I asked it to generate a list of ingredients. And I also want it to help me check whether these ingredients are in store, for example, in Costco or, Whole Foods. So I basically gave this prompt, and then I went to grab lunch, and by the time I come back, it was still working. And I felt so bad. I was like thinking about the trees that are being burned by.
Yeah. Anyway, so he goes through all that.
Specification-based approach. Basically, when a user gave a prompt like, I'm thinking about organizing a dinner party, it will first generate what kind of organization you may need for organizing a dinner party, and then it will map those things to a UI, and then the UI will be rendered as this environment. So let me give you some example. Right? Imagine I'm thinking of organizing a dinner party. You may care about people, location, time, right? And the UI specification will tell you, or guide the system, like, okay, what's the level of detail, what's the representation, and what's the interface organization that you may want to use. And then it will generate, put the right elements together. Now, you may have new needs or new desire for your activity, and if you have follow-up prompts, it will sort of try to change the activity specification, like, dishes, ingredients, or food restrictions when you're thinking about the menu, right? And then the activity environment will change. So you have this graphical user interface that GUI-based activity environment.
Yeah.
So basically, this pipeline works this, right? When the user have a prompt on their data, the activity specification will guide the system, like, okay, what are the information entities we provide? What is the structure among this activity? And the UI specification will basically guide the system to choose the right UI and then compose everything together. So on top of that, we also want the user to be able to directly.
Yeah, I mean, this is huge. This is really good research, and I think if there is a company out there who's paying attention to this, if they can crack this, I mean, it will be huge, because I think not only does it work for humans, but I think it will also work so well with agent-to-agent communication. Because, I mean, in the case of agent-to-agent communication, they can even bypass this part here and just get to this point really quickly, right? Because the agent can just send in the actual information about entities and specific activities that it wants to do. And based on that, I don't know, you can have some sort of plug-in system where you have multiple agents working together, and it's easy for them to communicate amongst each other to together morph the UI. And this really works, especially in the context of having the quote-unquote mythical everything app, because then you can have different agents that are in charge of different domains from different providers with data that are in charge of their own data. Basically, it's like streaming right now. We all wish we could just have one streaming app that has everything we want. Instead, we are forced to purchase all these streaming subscriptions across different providers. And in this case, you will basically have an agent for Netflix, an agent for I don't know, Max, an agent for Hulu, but it's all like one single pane thing. And depending on, maybe that's not a great example because that's all the same domain. What will make this more interesting will be having different domains. So maybe you have a Netflix plugin slash agent, a YouTube plugin slash agent, I don't know, what's another thing out there that people spend their time on. Anyway, the point is you can have all these agents that from different domains that work together to dynamically render a UI that is context specific.
Implemented activity specification, so that I can further adjust the UI based on my needs, because I know AI will make errors, right? And I also want to be able to adjust the UI, right? So I want to be able to adjust the overall information environment, but I also want to be able to adjust individual UI elements. And then eventually, hopefully, I'll have generated available in the personal activity environment. So does this work? So we have this pipeline, and it was like, will it actually generate something useful? So my PhD student Rima built this system, Jelly, which explores this pipeline and the efficacy of this pipeline. So I'm going to play a 4-minute video of a user using Jelly to achieve an information activity. So let's take a look. Let's look at how Millie uses system Jelly to help her relocate for a new job in San Francisco. She opens Jelly.
I'm moving to San Francisco.
However, Jelly thinks she's trying to figure out a moving plan, so provides her with moving services and a budget. She deletes the fields she doesn't need and further prompts.
I'm finding a place to live. Tell me about different areas. I've heard some of them could be sketchy.
Sketchy.
To support Millie reviewing how safe each area is, Jelly adds the safety level and relevant information to each area. To better compare these areas, she transforms the structure into a table and ranks the areas by safety level. She definitely doesn't want to live in this area and this. Commute time is also an important factor for her. She tells Jelly.
My company is on Market Street. How does the commute look like?
Jelly adds her company in the home panel and the commute time for each area in the table. It also suggests the 2 areas with the shortest commute time. Seeing this, Millie narrows her option down to Nob Hill and Mission District. She then asks Jelly.
What are the apartments in those areas?
Jelly then presents available apartments on the map with the details relevant to her interests, such as city level and commute time. After something.
Anyway, I've already seen this, but definitely recommend looking into this. It's very interesting research. Let me see if it's done something recently. Yeah, I mean, overall, this person has pretty good design test, in my opinion. That is based on the research things that I've seen from him. Best paper. Wait, language authoring of animated unit visualization. Data particles, a block-based story editor that average the latent connection. Spreading through the story, narrative and corresponding to inform the design of the. Okay. Supporting programming with interactive, contextual, and structured visual logs. Multi-level visualization. Multi-level visualization. So what? You select it and then you have the control flow. in the data view. Let me see if they have more illustrations, because this may be actually quite useful for editors. Okay, so you can click on each one. Can imagine there's so many details to figure out. So you have the program, and then you have the function call. Yeah, okay, so you put that in here. So you start with n is equal to 0. All right. All right. We don't have long now. Maybe I should just cut it. Now I feel like there's zero time for one more thing. Fuck it. Let's do at least 1 or 2 pages of this. Maybe we'll make it a regular thing this week as a follow-up to our Lingua Franca manual stuff. Oh wait. Blah blah blah. Proto. I'm just trying to see where. Gosh, you kidding me? That's ridiculous. Okay, so this is where I last stopped. Okay. Yeah. Okay. All right. I mean, this is the thing that's driving to dive into Lingua Franca recently. I mean, I've been aware of Lingua Franca, but I'm actually looking to build something in it, and there's definitely a lot of things that I like about it. And I'm hoping that by the time I'm done going through the manual, that I'm convinced that I want to use it directly for building something that has to do with whatever this framework that I'm prototyping in my head is. Yeah. All right, let's do some introductory stuff on ontology. Yeah, okay. Getting started. Overview. Ontology building. The Palantir ontology is an operational layer for the organization. Operational layer. Okay, the ontology sits on top of the digital assets integrated into the Palantir platform. Okay. So all the data and models and all that ultimately are they are made into stuff that's useful through the ontology. Okay. The ontology sits on top of the digital assets and connects them to their real-world counterparts, ranging from physical assets like plants, equipment, and products to concepts like customer orders and financial transactions. In many settings, the ontology serves as a digital twin of the organization, containing both the semantic elements, object properties, links. I think some people call these concepts instead. Anyway, object property links and kinetic elements, actions, functions, dynamic security, needed to enable use cases of all types. Object and link types. Defining the semantics of your organization happens by mapping existing data sources into objects, properties, and links in the ontology. The immediate thing that comes to mind is, well, do you need a single ontology or can you have multiple ontologies? Or do you have to somehow figure out a way to build everything into a single ontology? My hunch is that yes, you probably want, in an ideal world, you probably want a monolithic ontology, but I think it really depends on your level of maturity. Sounds funny. Maturity. Like if you're just getting started, it will make sense to have different ontologies that, well, okay, they shouldn't be completely siloed. You should still have an overarching goal of merging your ontologies incrementally to get a monolithic ontology. Anyway, far beyond data cataloging or schema design solutions, the ontology allows you to define a robust foundation for end-user workflows, including rich metadata for all fields and complete with granular security and governance for all changes. Learn about creating the semantic elements of the ontology, object types, and link types. Action types and functions. The kinetics of the organization. Okay, object and link types. And by link, I mean, it's just really, so, okay, this is like the relational model, but like pushed into basically it's not just tabular, so it's, you know, at a graph. You're really building a graph of objects and linking the objects together. And each object has properties. Anyway, action types and functions. The kinetics of the organization enabling change while complying with organizational controls and governance, or define the ontology using action types and functions. Action types enable you to capture data from operators in your organization. Action enable to capture data from operators, okay. To capture or to trigger? Okay, capture. Okay, capture data from operators or orchestrate this. Okay, that's the part. Okay, all right. I think that's more aligned with my trigger of triggering actions or whatever. Or orchestrate decision-making processes that connect to your existing systems. While functions provide a way to alter and evolve business logic with arbitrary complexity. Learn about creating the kinetics of the ontology, action types of function. Interfaces. An interface is an ontology type. Okay. An ontology type that describes the shape of an object type and its capabilities. Okay, so it's some sort of abstract representation of a class of objects, a kind of object. Okay, allowing for consistent modeling of interaction with object types that share a common shape. Powering decision making. The goal of investing in ontology is to facilitate better decision making in an organization at scale. To achieve this, the ontology is deeply integrated into Palantir's user-facing analytical and operational tools. Users can create reusable object views, search for objects of interest in the Object Explorer, perform complex analysis, quiver, build high-quality applications in Workshop, and more. Okay. Ooh. Okay. Why create an ontology? I think we'll read this and call it for today. Why create an ontology? Organization can gain several key benefits from building and using ontology to organize and leverage their data as described below. Connectivity at scale, interpretability, economies of scale, decision capture, powering operational AI, ML. In practice, These benefits are realized by using Foundry's ontology-aware applications, which enable rapid analysis, workflow development, and decision capture. Okay. The Foundry. It uses the ontologies Intel as a backend for applications. That's what that sounds like to me. Connectivity at scale. The ontology is a shared source of truth for decision making and decision capture across a large organization. By providing a single source of truth, the ontology enables users to easily discover and understand the data available across the organization, as well as view the local decisions in a more global context, providing connectivity at scale. The ontology is used not only to read data, but also to write data back and capture decisions made by users. Operating from standard data lakes can lead to unmanageable complexity from an ever-growing number of data sets, dashboards, and applications. Over time, increasing effort is required simply to understand what data assets exist or should be used, while new projects reinvent the wheel instead of reusing or leveraging existing data sets. In contrast, the ontology provides a well-defined system into which new information is modeled in a common language for the organization. With an ontology, organizations can make the most of the data as the data asset grows, enabling a digital transformation at scale while controlling complexity and reducing the difficulty of data management. Example, an energy company uses the ontology to create a shared view of the health and performance of a well across petroleum engineers, well integrity engineers, and well management staff. Instead of building several isolated views on the well performance, they share the inputs to the same ontology well object type, allowing short-term decisions about the well's management and long-term decisions around the asset's investment strategy to be generated from the same information and insights. Interpretability. The most challenging element of operating as a data-driven organization is deploying the data to the various decision makers across the organization. In particular, many decision makers are not technical users comfortable with code or IT concepts such as datasets or joins. Fair enough. The ontology abstracts away these digital concepts and allows users to engage with data represented in standard terms they use every day. More importantly, the ontology provides a shared language across different users and functions, allowing them to collaborate without lengthy reconciliation processes to confirm that everyone is looking at the same information. At a manufacturing customer, monitoring data from aircraft sensors was previously inaccessible to both operational users and data scientists due to its scale, complexity, and esoteric format. Today, because of the ontology models on top of the monitoring data, designers can search for parts, see related sensor readings that may signal unexpected or anomalous behavior. I feel like I'm saying that wrong. That's the French reading that's coming out. In French, we say anomalie. In That's the word that comes to mind in French. Anomalous behavior and improve feature design without needing to think about tables or ends up going through a complex data preparation process. Although this data was among the most valuable used for an organization under the previous system, the process of processing the data could take days or weeks, limiting the use of the data to special projects. Now, this data is immediately accessible not only to data scientists but to engineers, quality control specialists, and designers. Economies of scale. The ontology enables significant economies of scale in the construction of an operational platform by converging effort onto a single reusable data set that supports all analytical work and application development. Whew. Rather than requiring a dedicated data integration and data layer effort for every new use case or project, data integration is only required for new data entering the platform. Entire applications and use cases can be built on the existing ontology. Again, yeah, I kept thinking about, okay, do they mean you need to have a very singular monolithic ontology, or can you have multiple ones that can be, there are points of relations that you can link, but really it's fine to keep them separate. There are parts where they come into where you can join them, but in terms of domain separation, it will be fine to have different ontologies. Anyway, okay, so the shared data assetlets application builders focus on the organization problem and the user workflow instead of the data wrangling. Yeah, the data wrangling is so much work. Decision capture. As an organization's digital twin, the ontology supports data write back and continuous improvement by capturing decisions being made in the organization as data. The ontology allows for the configuration of write back and action types, which define how users can edit and enrich the data backing the ontology. Capturing decision-making outcomes in the ontology enables organizations to learn from and improve their decision-making. Data write-back also allows the value of the data sets or the data asset to compound over time, as insights captured by one user can contribute to the decision-making of another user. Powering operational AI/ML. For data science and AI/ML teams, the ontology enables collaboration with operational teams and others on a shared platform. Models and the features can be bound directly to the building blocks and processes that drive the organization. This allows models to be governed, released, and implemented directly into core applications and systems without additional adapters. Excuse me. Without additional adapters or glue code before being served in platform, batch streaming or query driven, or externally. As decisions are made and actions are taken, operational and process data are written back into the ontology, creating a feedback loop that enables model monitoring, evaluation, retraining, and MLOps. Foundry enables quick iteration towards outcome. The ontology and other best-in-class tooling make it easy to get started and deliver AI/ML-enabled operational outcomes, whether through new applications or by augmenting existing systems. Subsequent use cases can leverage interconnected datasets and model assets throughout the enterprise, decreasing time to value for new projects. Models in the ontology. Oh, here they literally mean, I think they actually mean AI models, not just an ontology model or model of an ontology. Anyway, we'll pause here. All right, it's late. I don't know what's the exit dialogue here. Besides that, it's late and it's time to call it a night. And thank you for being an audience, I guess. If any of this is interesting to you, please do like and subscribe, and I welcome any feedback. All right, thank you, and good night.